Okay, it's 11:01 Pacific. In fact, I chose to put this timestamp here on the front. This is read out of Syslog format, and it shows some of the problems that we'll be talking about today. So I'm just going to jump into this. We are recording this, so anybody who does join late, they'll be able to go back and see the beginning. First, we'll talk a little bit about Syslog in general today, and then some of the issues that are associated with it. I want to get to the Cribl pack for Syslog input, which we're really proud about. And then also we'll talk about architecture and sizing a little bit. Today's office hours are free form. So if you'd like to take yourself off mute and just shout out a question anytime, if it's relevant to the topic I'm on at that point. If you have other questions, you can send them in via the chat, and we'll be sure to circle back and hit all those at the very end. So first, let's just get this out of the way. So Syslog means different things to different people. And it's because Syslog is a heavily overloaded word. It means the protocol that we're using to transfer data from place to place. There's a Syslog message format, which the protocol uses. And then people talk about things like Syslog servers, which are simply receivers that are receiving data using the protocol in the message format. So Syslog could mean any of those three things. So we're going to tease that apart a little bit. I'm not going to go through everything on this page. This is from an older presentation that I gave once. But one of the key pieces that's in here that is relevant is that originally when Syslog was created way back when, it was designed around using UDP, which is very well, it was chosen because it's a little less overhead compared to TCP, but even more importantly, that was back in the days when servers, most servers on your campus, for example, would have one CPU core. And back then, it was important that these are servers with 4K of RAM back in 1987, and when this was all invented by Eric Allman, he was writing sendmail, but wanted to be able to log data, and that logging couldn't ever impede the delivery of the email. So email delivery was more important. They chose UDP. If the Syslog server itself went down, the mail server didn't even know it. So we still have that legacy today when we use UDP for getting data into Syslog. TCP is offered by some vendors, but not all. TCP does allow you to do fancier things if that vendor supports it, like Syslog with SSL. But not everything supports that. So what we're going to talk about is ways that Logstream will be able to help with getting the data from place to place. The most important thing on this page probably is that Syslog is ubiquitous. It was like the original API for inter-process communications between two completely disparate application stacks. So it's ubiquitous and it's universal. And in a lot of cases, you don't have an option. If you've got Cisco gear or Palo Alto firewalls or typically networking type of equipment, they support Syslog. They don't support installation of an agent or HEC or any of the other more modern ways of getting data out. So let's talk about the Syslog message format and just take a quick look at it. So here I've kind of color-coded what is actually coming in. Now this is just one of the many formats that are available, but what they all have in common is this first three pieces. So usually if you see this written down as inside of a log file, you'll see angle bracket, something, angle bracket. That's a combination of the facility and the severity. We'll talk more about that in a second. Then after that, you'll see the timestamp, which is human readable. And that was important back when people started writing data to disk because they would be grepping through these files by hand. And as a human, I needed to be able to read something. I can't look at a timestamp that's an epoch time and be able to process that easily. So that made sense back in 1987. Following that is the host field. And then the rest of this, in this example, is what's called the message field. And that's actually free form. If I am a particular vendor, when I'm writing the way that I'm going to code my device to send data outbound, there is no constraint on me as to what I can and can't do in terms of putting data in there, except for the fact that if I'm using UDP, it's got to fit within 2048 bytes. Sounded like somebody was shouting out a question, so I'll pause there. No time zone. Ew. Yes. If no questions, so I'll move on. I promise I'm not going to have too many more slides. This is just to set the stage. So some of the problems that you might be facing if you're implementing Syslog collection in your environment have to do with the fact that originally it was UDP and not TCP, and many devices don't support it. One of the people on today's call was mentioning that in his environment, they standardized on UDP because it was the one thing that they all do support. As I mentioned, UDP was designed around failure, but that also means that it's inherently lossy. Data might be dropped. As I mentioned, it's tied to 2048 bytes for the entire datagram. So if you needed to send larger than that, you have no idea whether that data is going to all get there or not. And originally, there was no time zone support. People today try to fix this by putting all their devices into UTC, which can be cumbersome and cause its own headaches if you're in the middle of the night and you're trying to log into a system and see when was the last time that thing was changed. You have to figure out, how many hours ahead is England right now? And then within that message protocol that we had here on screen, this bitwise thing at the beginning with the facility and the severity, here's some examples of facility. Kernel, user, mail, NNTP, because we use that, right? And then local 0 through local 7. There's a total of 24 of these facilities, and they are not sufficient to describe the wealth of sources and source types that you might want to use today. The next piece is that we do have severity in there. These are pretty good. So debug, info, notice, all the way through emergency. The farther you go to the right, the more important it is. The timestamp could be in any one of a dozen different formats. Here's the most common one. You'll notice that it's written out perfect for a human, but it doesn't include a time zone. And so I don't even know which time zone this is in. There's a host field here. There might be an app. And then, as I mentioned, the message could be any kind of format. So the Syslog format was originally written when Syslog itself was the destination. I quite happily remember SSHing into Syslog servers and running that command there, tail-f, rlog, maillog, pipe grep, whatever. And that allowed me to then see in real time the data that's coming through from the mail server or from the web server or the whatever it is. These days, though, we don't want to get that data just to disk on the Syslog server. In fact, it's almost never that that's where you want to persist that data. Instead, you want to get it to Elastic or Splunk or S3 or something else. And so what made sense on disk back then doesn't make sense going forward. You want to have a timestamp that's an epic time, so that a system like Splunk or Elastic or anything else can be particularly efficient about it because it knows exactly what that timestamp means if it's an epic time, and perhaps down to the milliseconds and so forth. Also, there's redundant fields in that data. So if I think about the way data might look when it lands into Splunk or Elastic, I've got an extracted field called _time. I don't need it to say APR space 3 space 01 :13 :54 because I'm never going to search on that. That's just redundant data. So what if I could strip out some of that data that's redundant? Okay, so just to recap what we covered so far, some of the problems are that UDP is lossy and it's impossible to secure unless you install a VPN tunnel. TCP does fix some of those problems, but it requires support by the vendor for TLS or SSL if you want to have that be secure as it's traversing across the internet. There continue to be time zone and source type issues, and there's that redundant set of fields that literally are consuming bytes on disk, but are never of any use because you're not searching them the way they're stored. So some of the things that we would recommend would be to, in fact, here, I'm going to jump to here and then come back to architecture. So here's a recommended deployment. Syslog senders might be sending in via UDP or TCP. They should always send through a load balancer. And then behind that, you have a log stream worker group of worker nodes that are sized based on the total volume in and out. It's pretty straightforward. But why a load balancer instead of, say, DNS? Or why use a load balancer at all? It's because each of these syslog senders is probably only configurable to use a host name or an IP address. And the load balancer's job is to make sure that that data gets to somewhere. Now, when you're just setting up a syslog architecture with the load balancer, you want to have this be as non-sticky as possible. The way Logstream works and is optimized, each of those worker threads does best if that data coming in is as distributed as possible across all of the worker nodes, worker threads in this destination. Let me say that again. You want to have that load balancer be non-sticky so that any of these syslog senders, the next packet that comes in, can land on any of those Logstream workers and have the maximum distribution across all those threads. And of course, when we're done with it, we're using the Logstream pack to address the issues I just discussed, source typing and timestamp normalization and so forth. And of course, then Logstream can send that data out to Splunk, Elastic, S3, or whatever it is that you want to send to on the right-hand side. Let me pause there for questions, because I'm sure there's got to be a few. I was taught to always wait for at least one question.
No questions so far for me. Doing great.
So what about a high volume sender? Like Ahmed asks, should UDP or TCP be configured for Syslog? Glad you asked, Ahmed. So in general, for lower volume senders, you want to make sure that data gets there. And if your device supports it, I would use TCP. But because of the way Logstream works, and the way load balancers work, and the way TCP works, there is a time when you have to shift from TCP to UDP, and that's when you have particular high volume senders. So for example, my Palo Alto firewall for one of my customers is sending about 700 gigabytes of data a day inbound to Logstream. If that came in through TCP, the load balancer would do its job and connect that TCP session to one worker thread inside the worker group. What happens when you do that is that you exceed the capacity of a single worker thread to handle that workload. So it's very important when you exceed the volume of about 300 to 400 gigs per day, that's when you must shift that sender from TCP to UDP. And why that works is because the load balancer sees each individual UDP datagram and routes it to a different worker different worker node, different worker thread, and you get maximum dispersal of that entire workload across all of these. If you left it at TCP, you'd essentially be pinning all of the data coming from that single source to a single worker thread. The load balancer can't distribute that. All it can do is disconnect it from one thing that's overloaded and reconnect it to something else, which will immediately become overloaded. So don't do that. High volume senders should use UDP. Otherwise, you use TCP if you can. Once that data gets to us, though, now we're able to do some pretty fancy things. So, volume reduction, redaction, enrichment, and all those other good things that Logstream is known for. But also when I send that data onwards to Splunk or Elastic or whatever it is that you're sending to next, we can encrypt that data stream. So regardless of how it came in originally, whether it was UDP or TCP, it's going to go out nice and secure. It's going to go out TCP and using persistent queuing on our server. If that destination is down temporarily, we'll make sure that data doesn't get dropped. So the recommendation in general would be to deploy the right number of workers as close as possible to those syslog senders. So most things that are workloads running on the cloud they're not generating syslog, they're using more cloud native ways to get their data from place to place, things like CloudWatch or writing their data directly to S3 or to Azure Blob Storage, that kind of thing. So syslog senders tend to be network devices that tend to be on-prem. And so the recommendation would be to deploy a couple of workers on-prem behind a load balancer on-prem to collect that data as close to the source as possible so that you minimize those risks of lossiness due to UDP, and so that you can get the benefits of volume reduction, enrichment, and so forth before you traverse that data across the wire out to a cloud destination, perhaps. So let's see, collect as close to the source, covered that. Sizing, if you're doing this kind of thing, this would be sized by that site. So if I have a terabyte of data coming in New York, and I have 4 terabytes of data coming in Los Angeles, I'm going to deploy the right number of workers in New York for New York, and the right number of workers in Los Angeles for Los Angeles. Each will have their own load balancer. All the local source Syslog senders will go to their local load balancer and thence to the worker group. Now, that doesn't always work out in the real world because perhaps the team that owns load balancers doesn't talk to you. Or maybe, I don't know, I've heard of one customer that didn't have any. Seems weird. But this is the general recommendation right here. Finally, a lot of these Syslog senders don't support the option to change the port on which it is being sent to. It's going to send outbound via Syslog UDP to port 514, and the only thing you can configure is the IP address or host name of the destination, which should be that of the load balancer. For the workers to listen on port 514, that's a protected port. You can't listen on ports under 1024 unless you're running as root, which we don't recommend. Don't do that. Instead, you can use the setcap command to tell that operating system to allow the log stream binary itself to be allowed to listen on port 514. Alternately, you could have us listening on port 1514 or something over 1024. The load balancer will listen on 514 and simply redirect that traffic to a higher port on this side, and thereby you avoid that issue altogether. Let's see. Yeah, that's that. So before I shift gears, let me ask if you have any questions so far, or put them on the chat. I see some in the chat. I'm concerned about security and UDP reliability considerations. UDP support is not reliable. Yes, I agree. You can't use it if, yes, I agree. You shouldn't use UDP if you have TCP as an option, but you won't always. How we control all syslog to assure UDP checksum are not disabled, as IPv4 syslog should check UDP checksums and should accept a syslog message with a 0 checksum. That's a good question, Iman. I hope I pronounced your name correct, Lee. I don't know the answer to that, but I'll get back to you. We do have checks built into Logstream itself. So when data is coming into ours, and the data doesn't look correct within the packet, or if it's not following the protocol, there's a syslog fail flag, which we'll show here when I get into our pack. But in terms of things that are happening at the lower level transport, that's outside of my expertise. Paul mentions, unless you're using the AWS network load balancing with UDP, it uses a 4-tuple system. Oh, great. Yeah. So, yeah, the way that's working is not optimal, right? So as I mentioned, you want the load balancer to be as non-sticky as possible. Most load balancers, you just turn off that feature and it will distribute that workload. It sounds like the NLB is special. Okay, so let's go ahead and take a look at the next piece. Feel free to shout out a phone call, a question if you have one in real time. You don't have to put them on chat. You can just shout out. The log stream.
I did have one question.
Yes, Jeremiah.
Just because I joined a little bit late. Mm-hmm. So in the last slide, the load balancer is on customer prem to receive the syslog servers and basically handle the connections.
Yeah, and the worker would be too.
Okay, so the load balancer makes direct connections to the workers.
Mm-hmm. Yeah, so the normal, in fact, I skipped a step here. So that load balancer, perhaps it's an F5 that would, so this is, remember, these senders are most likely in a data center somewhere, or a virtual data center, but they're probably networking devices. And so the presumption here is that you've got a physical location where these things exist.
Okay.
And almost everybody, anybody on the Fortune 500 has load balancers. Every network, every federal agency and government agency has load balancers. If you've got the ability to make sure that data has to get to one of many targets, that's what load balancers do. And so the Syslog senders would send to the local load balancer, which would send to a local worker group, preferably on the same LAN, or at least on the same site. And then from there, that data could go to wherever it needs to go. Does that answer your question?
Yeah, so load balancer most likely is going to live on the same site as the Syslog sender. It could also live on the same site as the log stream. But
it should live on the same site as the Syslog sender and the log stream together, because they should all be there.
Got it.
If I have, and the example I had was if I have two sites like New York and Los Angeles, I should absolutely have log stream workers in both locations. That way I capture the data as soon as possible. And then from there, I can route it, maybe all my Elasticsearch, destinations are in New York. That's great. My log stream worker group in Los Angeles will quite happily send securely and reliably to Elasticsearch in New York.
Okay, cool. Got it.
Okay.
That makes sense. We want to have log stream as close to the data source as possible.
Yeah.
To avoid any stream interruptions due to network. Got it.
Right. And that's not just for Syslog. That also applies if I'm pulling S3. I would want to have that, if it's AWS S3, I'm going to do that in log stream workers running as EC2 instances or in Cribl Cloud. If I'm pulling from Azure Blob Storage, I want that to be workers that are running as Azure VMs. In all these cases, I want to get the collection of data from pull-based sources or push-based sources as close to the source as possible, so that all the benefits of volume reduction and the cost savings that go with that will also be part of the overall solution there.
Mike, this is Iman. Sorry for interrupt, but this is not going to happen, right? If I understand correctly, you try to do that to make sure that you are not by switching to the UDP faster, but you accepted the lack of congestion control mechanism, which might happen. But for that reason, you're changing your architect to have everything as close as is possible. But for some customers like us who has so many data center across the whole entire world running on the AWS platforms, what should we do then? We cannot create all the workers in each of the data center that we have, and then keeping 2 of them right here, 4 of them on another side and such, and then make sure that this UDP protocols is helping us.
Right. So remember what I'd said earlier, though, is that if you have the ability to send via TCP, and so long as it's not over that 400 gigs of data per day, you should use TCP.
Right. Yeah, because you are killing your TLS transport. You only relying on layer 2. I believe UDP is good for the small amount of the data that you're transferring, but having Syslog in so many places and then only rely on the load balancer, have everything close by, it's going to be mandating your strategic deployment to everyone.
The scenario you're describing is different than what we see with most of our customers, where Syslog senders are those legacy devices that exist on-prem. You've got something else going on. I'd love to talk with you at greater length, and we can come up with a custom solution just for you guys.
Yeah. No, Ahmad already know that. For example, we have a Syslog sitting in China or Australia or Frankfurt, and they are all sending to Splunk. Having them, it's not going to be happen that way. Anyhow, sorry for the interrupt. I just want to make sure that I understand, and I believe I've already catch that platform that you guys are putting in the perspective for us.
Okay, so I would love to learn more about your situation, and perhaps it'll the next version of this presentation that I give will factor in what I learned from you. However, the gist of all this is get the data from your Syslog senders into Logstream. So however you do that, let's talk about what happens next. So let's see, make sure I don't lose anything here. Yeah, got it. So we're done with slides. So first, if you just go to Google and type Cribl dispensary and hit search, you'll get our pack dispensary. And this is where you'll find all of the packs that Cribl has created, as well as the packs that will be created by some of our customers and partners. The pack that we'll be looking at today is called Cribl Syslog Input, and if you click on that, you'll find more information. If you are new to downloading things from GitHub, just go over to the releases, and then from there you can find the .cribl file. That's what you want to download, so you can then push it in, upload it into your Logstream environment. So here I've jumped into Logstream, and here we've already got that pack installed. And what I'm showing is the README that came with that. So with each of our packs, and I'll navigate to it here, if you go into the pack itself and then go to settings, there will always be a README. So this is your self-included instructions on how to begin the configuration and use of a given pack. So here you can see it's talking a little bit about some of the benefits and some of the things that it does. The rest of that pack, if you switch over to the pipeline itself, in the case of the Cribl Syslog Input pack, it's designed to handle data as it's coming in. So not in the normal sense, but as a input conditioning pipeline or as an input filter. So it's going to do some normalization across all the different kinds of Syslog senders that you might have, so that I can do fancy things like look up this inbound host name so that I can automatically attach an index, a source type, a source, a time zone to that host, to that individual sender. All the different things that today you have to be done in 4 different stanzas in Syslog NG, plus a matching stanza in a forwarder configuration from Splunk or Elastic. All of that gets rolled into this one pipeline. So I'm not going to go through each individual piece of this today. I will point out a couple things like this. It's going to do a check to see if it's valid syslog or not. If it's not, then you get to choose what happens next. Should you just pass that on? Should you drop it on the floor? That's up to you. There's a lot of automatic timestamp normalization in here. So with regards to this pack, one of the things that we do is we see, does it look like this device is sending exactly 2 hours ahead, or exactly 8 hours ahead, or 44 minutes behind? In the case of 44 minutes behind, I'm not going to be able to automatically detect that it's probably just in a different time zone. Whereas if I see something that's within a tolerance that looks like it's just exactly 2 hours ahead, exactly 4 hours ahead, it's more likely than not that that is just a different time zone, and some normalization based on now can happen. We had one customer that turned this on. They had literally 200 plus Syslog senders, and for the all but a couple of those Syslog senders, it took care of all the timestamp, all the normalization for devices across the world, all automatically. So you don't have to go in and configure everything, but in their case, they were then able to use the lookup file that I'll talk about in a second to do the rest of it. All of this is commented. So our encouragement for any customer with any pack, whether we create it or not, is to go through and read through the sections and the comments. It talks about how it works. If you have any questions, you can reach out to the author. In this case, this is written by me, so you can hit me up on the Slack channel. After timestamp normalization, the next thing that happens is that sometimes the timestamp within the message field is actually the timestamp you wanted, as opposed to the one that's at the beginning. So the auto timestamp function against the message field allows me to do something where perhaps I've got a Palo Alto firewall that's sending my data in, and I don't care about the original syslog header. I care about the one that's the second one in. This will pick that up automatically. After timestamping, we're going to do some volume reduction, which I'm going to show right now. So let's go ahead and bring up some syslog data here. we're going to start with the in. So if this were my data set coming in, I've got the message format that we talked about before, right? You can see I've got that severity and facility information here at the beginning. I've got a timestamp that's in human readable format, but not particularly good for a computer. I'm missing a time zone. I've got a host name, in this case, M. Donnelly router, and then I've got an app name, and then the rest of this is the message field. So let's start by looking at some of the redundancies that are there. So first, this timestamp and this timestamp are redundant. I'm never going to search for NOV space 18 inside of Elasticsearch or Splunk. There's no reason to bring this data in at all. So what if we could just drop it, knowing that we have underscore time already extracted and extracted right. But there's another piece about what Logstream does with data coming in via Syslog. By default, it's going to extract all these individual fields for you without you telling it to do so. This is different than all of the other sources that you might configure inside of Cribl. So the PAC's job is to remove the fields you don't need so that you don't have redundant data from the extractions being sent onwards to Elasticsearch or Splunk or S3 or wherever. So you can see here that this piece to the end is the same value as I have here in message. I certainly don't need to send both of these onwards, but I might want to use message as a way to recreate what's going to be sent out in raw. I also have facility 18 and facility name local 2. Those actually mean the same thing, except one is human readable and the other one's not. Likewise, severity 6. What is that? I'd have to look it up. But Cribl already extracted that for you on the way in, so its severity name is info. So I want to reduce what's being sent onwards by stripping out the redundant fields to the ones that make sense for me in my environment. So if I'm optimizing for readability and usability by somebody who's kind of junior, I'm going to send facility name and severity name onwards. I'm going to drop facility and severity because they're redundant. I don't need the host name up here in the message field anymore. I've already got it as an extracted field, and I don't need the timestamp. So let's go ahead and take a look at out. And this is the result of all of the rest of this cleanup that's happening here on the left. You can see that the time has been removed, the host name's been removed, and so now we're down to just having that piece of it and the rest of the original message. Down below, I'm looking at some of some other information here. I'm seeing source type and source that are being configured. I didn't do anything to put that in yet, so we'll talk about how we got that in a second. That's the short version is we got to look up for it. And if we take a look at the volume reduction, that's why we're doing all this. It's almost 30% volume reduction by simply stripping out fields you didn't need. Now I'm looking at underscore raw here. So that's 30% less on disk, 30% faster searches in Elastic and Splunk. So the reason I'm doing this is to improve my performance and to not have to search past all of the other fields that I'm never going to look at in this sense, but that I would look at if I were, performing a query in Elastic or Splunk. I'm going to specify my time range inside of that environment, and that's going to be using that underscore time. Right. So hopefully that makes sense. Let me pull up one more example here of another kind of data set. So we've got data coming in here that is similar to that message format we saw before, but this is another one of the timestamps that are available inside of the Syslog protocol itself. So in here, we're actually seeing that it has a time offset of the time zone. And in this case, it's 5 hours offset. And so you actually are being told right up front, down to micro precision, this many milliseconds, and so on and so forth. Well, that's still useful to humans, but it's not useful to me as a person that's receiving that data and parsing it. Also, there's this other information that's being provided. This is a newer version of the Syslog RFC, that's sending us other information that's kind of meta information about the payload of the syslog itself. It could be useful in terms of debugging, but I don't need to send all that to Splunk or Elastic. That's a lot of bytes used up for something that's not actually useful to me. So there too, if I want to be able to strip this data down, I'm getting 73% volume reduction just by stripping out and getting down to the pieces of the message that do matter. So 73% volume reduction in this case, 25 to 30% volume reduction in some of the other use cases. If I go back to here, here's some networking gear. I had that first. And then finally, some data coming off of a Linux server. All this information gets volume reduction. If for no other reason than that, this is a benefit for you. But it's not just for that. It's also the other benefits like timestamp normalization and the piece I'm going to show next, which is, come on, Zoom, get out of the way. Come on, Zoom, get out of the way. Drop this. There we go. You know how Zoom has this thing that pops down from the top of your screen? And if you get too close to it, it pops down. Okay, so within the pack, there's an example file that ships out of the box. And so if you look into it, you'll see that we have just a CSV. And this is how we provide that additional meta information that's so important, because if you are replacing syslog ng or rsyslog that's writing out to a regimented file directory structure so that your agent can then use that file directory structure to map index and host name back to it. This is performing all the same thing, but in a much more easily configured way. Everyone knows how to edit a spreadsheet. That's what we got here. So I've got a column that's for host, and that could be the IP address or the host name. And that's the thing that we're looking up, and that matches against the host field as it's coming in from that syslog sender. Next, though, I can now map the index, the source type, the source if I want, as well as the time zone. So if I had a particular set of 5 or 10 or 20 hosts that I know are in a particular time zone, but the rest are UTC, that's great. I can even turn off that auto timestamp function and just use this as the way to automatically make sure that those particular hosts that are spitting out data that's offset by 2, 4, 12 hours, that they're being dealt with correctly. So this spreadsheet is real easy, and you could even automate the creation of that by whatever system that you've got that tracks all the networking gear in your environment. Dump that out as a spreadsheet, import it into the master, and then you only have to come back and touch it when you add new syslog senders. Automate it if you're constantly creating them, of course. And then that data then becomes used by these additional fields that are down here. So we're trying our best to set all that meta information using the source IP or the original host field, or in some cases you even just hard code it. It went through everything else, it didn't match anything. So in the case of this guy over here, the source that I had for one of those senders was showing that came in via syslog on UDP, and that's the source that I'm using. So that's the pack in a nutshell. Gets you all the fixes for all the problems that we talked about at the beginning of today's presentation, except for getting the data into Logstream in the first place. And this is where I stop and ask for questions. Oh, let me actually make sure I didn't have any other things queued up here. Right. Oh, so let me show you how this works. We're going to just add Palo Alto as a new syslog source. Now, my PAN firewall is going to be sending 500 gigs of data a day. So do I use TCP or UDP? That's right, I have to use UDP. And even if I'm only sending to one host, at least it's going to spread across all the worker threads on that one host. And I might do that if I didn't have a load balancer or if I wanted to have a dedicated host for that firewall. But in general, again, use the load balancer. So let's say I've got this coming in on port 1527. And I am going to do a couple fancy things here. So first, rather than rely on that spreadsheet that I had, many customers that we talk to have dedicated ports for a particular class of sender. All of my Cisco switches are sending on this port. All of my Ubiquity switches are sending on that port. All of my wireless access points are sending on this other port. So if you can map things down on an individual port basis, then that becomes really easy. I can actually just type in index right here and hard code that. And maybe I hard code the source type right here as well. And then these will be preserved by that pack. If these already existed on the way in, the pack's going to just let them stay there. Now, the important part is that I have to select that pack as the pre-processing. So I go to pre-processing, pack, Cribl Syslog input. And that'll ensure that all data coming in on this Syslog receiver will automatically be pre-processed by all the steps in the pack before it then goes on to the next pipeline or the next route. If I hit save, I have now created that as a PAN firewall. Now I'm using the new quick connect function here. Let's say I want that Palo Alto data to all go to S3. I just do that. I'm going to send that pass through. And then I'm going to send all that data also to Splunk. But in this case, I want to use the pack that Brendan Dalpay wrote. And it's going to automatically do some additional things to that data. And as soon as I hit commit and deploy, boom, I'm done. I now have a nice, easy, efficient way to receive Palo Alto data on a dedicated port. I'm hard coding in the meta information. I'm routing that data off to Splunk. I'm also sending that data off to S3. I've done the timestamp normalization regardless of the destination, because that's what an input conditioning pipeline or pre-processing pipeline will do for you, so that I don't have to do that redundantly for each destination. That's it. So at this point, I'll stop sharing, or well, I'll just open it up to general Q&A. Let's say you wanted to talk to your coworkers about all this. I wrote a blog about this already. So if you just type Cribl blog syslog and hit return, the #1 hit will be this blog, which basically talks about everything I just did, but in a less technical manner. Okay, so there we have it. Questions?
Sorry, I showed up late. Is the pack out there on the dispensary right now?
It is.
This new one?
Yeah,
Okay.
if you go to the Cribl packs dispensary, you'll see Cribl Syslog input. This is 1.1. If there's anyone here who played with the earlier version, you should know that packs, once you start playing with them, you have to kind of throw it away to install the new one and see all the changes that are in there. What I would do if you had the older version is just install it onto a test instance, take a look, see if it makes sense for you, and then bring that over to your production environment.
Okay, thanks.
Mm-hmm.
What version of Cribl you're on? It looks different. Log stream, I guess.
Was that, were you asking me a question? I didn't.
Yeah, I was saying, what version of Logstream you on? It looks different with like the packs and pipeline.
Oh, I'm on the latest version, 3.3. Or what is the latest release?
3.2 had the
3.2. Sorry. Yeah, I'm on the latest released version. Yeah, so when you are on your Logstream worker, if you go to groups and select your group, and if it doesn't look like data sources, destinations, routing, data routes, quick connect, then you're probably on the version that was shipping up to about 2 weeks ago. This pack will work on the older 3.1.3 and later as well. Let's see, what do we see on the chat? You're welcome, Iman. Iman? How do I pronounce your name? I'm sorry.
Iman, that's okay.
Iman, okay. Yeah, let's set up a time when you and I can talk about your particular deployment. If you ping me on the community Slack channel, I'd appreciate it. And then you and I can dig in on that.
Sure, I will sync up with Ahmad and then
Okay,
we'll do.
excellent. So the floor is yours. Anything else?
Related to Syslog or related to anything Cribl related?
Well, now we can, yeah, if there's no syslog questions after all that, then we can go to anything you want. Stump the chump, I'm the chump.
Okay, since no one else is speaking up, I've been really drinking the Kool-Aid lately with Cribl, and we're going to be creating an observability data lake, just like it's been up on the blogs a whole bunch recently. The idea is to send the full fidelity logs to S3, and then we send the trimmed logs, reduced logs, reshaped logs, all that good stuff to Splunk. I'm looking at the partitioning scheme that we would use for the S3 output.
Oh, right.
If we separate things by index, and I'll just attach the destination to the output router we already have, because we have an output router for each of the 3 indexer sites we have. So if I just drop the S3 destination on there, I think and I configure the filters right, it'll just send automatically to that one as well, in addition to the Splunk indexers. So if we partition things based off of index, source type, and host, we would have about 3,000 different files that would be created per hour. And I'm getting that number just by running a tstat search inside of Splunk, just count by index, host, and source type. 3,000 seems like a lot, especially since the max open files by default, I think, is set to 100. So I was wondering if there are any kind of best practices documented about what the different settings should be for like max file size, max open time, idle time, and max open files.
Yeah, so luckily, Ahmed Kira is our expert on all things related to optimization for S3. So I've asked him to answer.
Yeah, your timing is impeccable here, Paul. There's going to be a blog that's going to come out in the next few weeks here. And maybe 2 office hours from now, we're actually going to go through this as the topic of how to write up to S3 in an optimized fashion. 3,000 files is really not that bad. We've had customers that have had tens of thousands or even millions, and it kind of can get out of control when a case like that. But 3,000 is really not that bad. But yes, to your point, you do want to adjust things like the maximum number of open files setting. Probably a good one to start with. And that is per process in our UI. So that is a per worker process number. So if you have 14 worker processes and that number is set to 500, then you'll have a maximum of 14 times, so you have 7,000 open files in a case like that.
Okay, so the max used disk space would be the max file size times the max number of open files times the number of worker processes on the worker node.
The max disk space is that says per file. Yeah, that's a per file size.
Yeah.
So to size the disk, probably the best measure is to see how much data that you're going to be writing to S3 as a whole across all your data sets, and then just divide by the number of workers that you have that are going to be writing to S3. And then from there, you can, add a little extra wiggle room just in case, you exceed that volume. So that for the file size, that would probably be, one of the measures there. But what else?
I'm going to have to map this out because we have the buffer that the worker nodes are going to be using to send to S3. And then we also have persistent queuing enabled to our Splunk environment. So I got to balance it between those two. Might just have to go back and increase the EBS volume size on those worker nodes. Just fine.
And since you're doing persistent queuing as well, might be a good idea to have a different EBS volume for it. It's not required, but for say persistent queuing versus the staging for S3, just to minimize, conflicts as the number of files grow in the system. There is also another setting on our side that remove empty directories. That we should have that enabled by default. I've got a Jira internally open to just have us enable that. And then if you have not had that enabled up to now, there's a command that you can run to basically delete empty directories. And so I would run that command just to make sure that your system doesn't use up all the available inodes.
Yeah.
And somebody's saying, thank you, Michael. Yep. Remove staging directories.
This is off by default. It should be on by default. If you're going to use S3 for outbound, always make sure you turn that on.
And in your case, Paul, it's probably not going to be an issue, but one thing to be aware of are the AWS API limitations, where it only allows you 3,500 writes per second and 5,500 reads per second to the API. There's, when you go into the S3 console and go to the particular bucket that you have selected, you can enable some CloudWatch charts to basically trend the number of reads and writes that you're doing there to that bucket. So you can at least make sure that you're not coming close to the limit. It doesn't sound like in your case you'll come across that limit, but if you do a lot of replays, perhaps you might.
Is that a per bucket limit or a per account limit?
Great question. So that is a per bucket and prefix, per bucket and prefix limit. So this is where you'd want to have multiple bucket and prefixes. And a prefix is not the same thing as a partition expression in the Cribl side. Think of partition, the prefix, think of it as more static, or perhaps you'd have it by source type or by region, perhaps, things like that. But yeah, it's a per combination of bucket and prefix that limit is applied to.
Perfect. I was just going to get worried if it was per account because we're also using Smart Store in that region on the Splunk side, and I don't want to impact Smart Store.
Yeah. Well, yeah. So more to come in probably about a month here. First session of the new year is going to be a lot of what I just talked about, plus a few other extra tidbits there to be aware of.
Yeah, I think you've got a blog coming out too, Ahmed, right?
Yeah, exactly.
And of course, all this will end up in our best practices documentation. And we're also working on customer training that goes beyond the sandbox. So for certification, if you want to get your CCOE, Cribl certified observability engineer, we'll have a cert program that's going to be starting to roll out in the year to come. And this kind of best practices will be part of the advanced topics.
I'm laughing because I just went through the S3 training again this morning, just to refresh my memory on that. So yeah,
The sandbox.
I don't think I'll wait until the sandbox. I don't think I'll wait until the blog post comes out. I'll just YOLO this into prod and then tweak the settings from there.
Also, make sure you don't have antivirus turned on to scan the staging directory.
Yeah,
that's
exclusions for that.
Known here to
or persistent queue directory either, for that matter.
Exactly.
I think we just grab everything in opt Cribl and exclude that from antivirus. Yeah, Sean Engelson is on my team. He's on this call too. He always loves it when I YOLO stuff into prod.
Okay, we have 5 minutes left, but if so, the floor is yours again.
I actually had a question. So as we were playing and tweaking with some of the Cribl functions, there's so many ways to skin a cat. I noticed that depending on how you stack up the functions themselves, it actually has an ROI. It changes the ROI, right? Is there some type of documentation or some type of blog? Because you want to get the maximized ROI and it's very dependent on how you use the functions, whether you use eval versus reg extract and so on and so forth. Is there anything that, any examples or anything that will cut down on the ROI itself?
When you say ROI, what are you,
The
how do you define?
statistics. So the length and all that stuff that as you look at the statistics, dependent on the stacks you create on the functions themselves, changes the ROI itself. So I know talking to Duca, he's been saying that, it can save milliseconds to some seconds. And, I know that's to
Right.
customers, that's big.
Yeah. So when you're within a pipeline, and let me go ahead and just pull up, I'm sure I still have it. Here we go. So there's two kinds of ways that you might mention. So most of our customers, they think about ROI any of 5 different ways. Volume reduction is one of them, but also the performance improvements that you get inside of your systems of analysis that you're sending to is another. But I think what you're asking about specifically is, how do I make sure that this is as efficient as possible so that it's taking as few milliseconds as possible for a given event? Is that how you're using it?
Yes.
Okay. Yeah. So in terms of that, poorly formed regexes can kill you. Anything where you're doing data enrichment against a non-local source can kill you. The goal would be that any given event can be processed within about 3 or 4 milliseconds total. So if I have something where I'm using DNS enrichment, for example, and that DNS enrichment is taking 30 or 40 milliseconds to come back, then that can seriously impact my performance. But most of the things that we're able to do inside the product itself, except for a badly formed regex, will not substantively change the overall performance. So the places I would start with in terms of making sure that you've optimized the way that your pipeline is constructed for any given data set would be to make sure that the processes that you're going to do all the time are right up front, especially if there's things where you can drop or exclude data sets from your search, and make sure that your regexes are as efficient as possible. And any kind of enrichment that you're doing, make sure that you've got a keen eye to optimizing that as much as possible. DNS has a great solution. Use a local caching name server. We recommend that on all your logstream workers if you're going to use DNS for enrichment at all. And that way the cached results are being held at the operating system level. Yes, you have to pay the penalty the first time you look up that IP address or host name, but all the rest of the times until the TTL, they'll be like coming back in sub-millisecond. Using Redis for enrichment, where that Redis server lives on the same local subnet, is another great example of a way to reduce the overall time for an enrichment lookup. For specific instances and tuning, what you can do, of course, is to at the beginning of your pipeline, you could actually insert a start time, and at the end of your pipeline, you could insert an end time. You have 1,000 examples in your sample, then you can actually look at the first start and the last end, divide by 1,000, and figure out for yourself, what's the average time across your data set. And then you can see, if it's less than 3, you don't have to worry about it. If it's 20 or 30 milliseconds, you want to figure out which of your functions is causing that performance issue.
Michael, I was also just posting in the chat that the CPU profiling, which is next under the gear icon there, could also be another way to benchmark pipeline performance.
Yeah, in fact, we should cover that on our next one of these things. We're out of time. I want to thank you all for joining us today. And if you have any follow-up questions with regards to the Syslog pack, hit me up directly on the community Slack. Otherwise, happy computing, happy observability pipelining, and have a happy Wednesday. Okay, bye, y'all.